Okay, so we are on to video assignment 2 for chapter 11. So it's asking us to basically asking how you can tell apart copper 2 sulfate, right here, CuSO4, between that and copper sulfate pentahydrate, which has 5 moles of hydrogen or of water involved in there. So first of all, I'm going to explain mathematically how you can tell the two compounds apart. The equation that we can use to kind of mathematically tell the difference is this one right here. The change of the freezing temperature is going to equal the Van Hoff factor I. In this case, both are going to equal 2 because when dissolved in water, Cu and SO4 make two different molecules that they break up, and so there's just 2 of them. And water doesn't dissolve in water, it's just water. So I is going to equal 2, the Van Hoff factor is going to equal 2 on both. M is going to equal the moles. And so in this case, say you have 5 grams of copper sulfate, 5 grams of copper sulfate pentahydrate. There's going to be a greater amount of moles per in those 5 grams in the copper sulfate. There's going to be a higher concentration of moles of solute involved there than if you took the same amount of grams of copper sulfate pentahydrate and dissolved it in water. So the moles are going to be greater on this end, on the copper sulfate end. And the Kf constant is going to be constant for both of them because it's copper and copper sulfate in both scenarios. So using this equation, we're going to find that the change in temperature, freezing temperature, is going to be greater on copper sulfate because there are a higher amount of moles per equation, per 5 grams, as an example. And so we're going to be able to tell that on a graph, which one is which. For example, we have time, temperature, and here we have an example of 2. From what we already know, this is going to be copper sulfate pentahydrate, the higher one, and the lower one is going to be the copper sulfate. And we know that because with, as shown with the mathematics, it's going to dip a little bit deeper with a higher amount of moles of solute than it would in this example because there aren't as many moles, so that's going to be the higher one. And we know that the more moles there are involved in a solution, the higher concentration. That means the freezing temperature is going to be lower, and the freezing point depression is going to dip down more. So that is how we were able to tell that. And I think, yep, that is everything for assignment 2.